Right, okay. Let me talk you through the homework that you have, the end of chapter questions, very briefly. First of all, explain what is meant by center of gravity. This is a definition, the point where the weight of a body may be considered to act. The wording is important, right? You cannot say this is where the weight acts, it's where it may be considered to act. So please just take a note on that. Define the moment of a force about a point, right? So this is related to the formula, force times perpendicular distance from the line of action of the force to the point about which the moments may be considered. Okay, so we even say to the pivot. And then the working the solution of BI, right? Always when you're busy with mechanics, draw a picture. This is why I have my picture drawn. Then state the theory. Sum of clockwise moments is equal to sum of the anti-clockwise moments. Force times perpendicular distance, and state the formula, substitute the value, and then we get to 60 Newton. Right? The last part of it, now there's a bit of a shifting going on. We have the weight of the plank. Remember, if it's a uniform plank, object, pole, whatever it is, it's always considered to act in the middle of the object. If it's non-uniform, they must give you additional information. Again, same thing, draw the diagram. Make sure you see which forces tend to rotate it clockwise and which anti-clockwise. Do the substitution and we get to the force or the weight of the sandbag is 255 Newton. Okay, so not a problem hopefully. Okay, then we look at question number 6 with this flower basket being blown by the wind. Draw your force diagrams. Right? So if I can just, that's your Cartesian plane. Always start by drawing the weight down. My next force that I'm going to indicate is the wind, blowing it directly in a horizontal position. And then the tension in my rope, or they say it's a rope, so that tension, right? That's 20 degrees, that's 7 degrees, 70 degrees, and we sit with a 90-degree angle. Now, because it's a 90-degree angle, we can use our basic trigonometry, cos 20, weight over ft. Remember, it's adjacent over hypotenuse. We can calculate it. It calculates to 37.2. They wanted to show that it's 37 newtons. So yes, we have the answer. But remember now, because they asked us to show that it is 37, in our follow-up question, we're not going to use the real value that we calculated. We need to use the value that they supplied, the 37. And this is the reason, because then it works out perfectly to 12 Newton, the force of the wind. Okay, so I used Pythagoras. You could again use your trigonometry and you would get to the same answer. Question number 7, the paraglider. Oh, this is what you've done now a few times already. So this is actually our paraglider. This arrow should be in the opposite direction. My drawing, it boils down to exactly the same thing. My f of y is 106 Newton and f of x is 152. Draw your diagram. These are the forces working in on my paraglider. Look at my work, must be straight down. That's the tension in the rope, the applied force by this motorboat. And then you have your force of the parachute, but it's not directly opposite to my tension. it is slightly askew. Why? Because we need to balance out those two forces. That's a resultant force almost to those two. Not a resultant force, that force cancels out those two. Sorry, it brings it into equilibrium. Forget about the resultant. Apologies, no resultant force. Nothing is accelerating. It's moving at a constant velocity. It says constant velocity. So it means we must form a triangle of forces facing in this direction. Okay. Last question, talk of a couple. All right, so this is a specific situation. There's a definition for you, what is meant by it. But look at this picture, it defines it very well. So I made a mistake there. The distance is the distance, not, that's the distance. Apologies for that. The distance is the distance between the two forces, between the two lines of action. So my distance is that. And that's the difference between my torque and a moment. For a moment, it would be a force, and this distance from where the force acts to my pivot. But for a force couple, it is the distance between the two. Although what I wanted to actually indicate in there, let me use this distance r and that distance r would be the same. That is true. That is 100% true. The two forces must be equal as well. It's F. I didn't say half a F and 2F, it's F and F, so it's the same force. Same distance from the pivot. Think about a normal tap, these old type of taps that you opening and you're turning that, or a propeller on a plane. That is the same thing. The action is it, and it's the distance between the two forces that we have. All right, so a specific moment. Let's call it a specific moment. All right. Then they want us to calculate a few things. First of all, in BI, state the magnitude of the angle that should be used. Well, for the minimum force to be applied, if this is 90 degrees, your force is going to be the minimum. Right? So literally, if I have a force working in there, and it's a 90-degree angle, there's force. If I'm applying my force at an angle, remember now there's an x and a y component, and some of your force at an angle is going to go wayward. It's not going to work down. I'm interested in that y component thing. So if my force is in that y component direction, the whole force, that means at an angle of 90 degrees, I have a maximum effect on the torque, right? And then just a basic calculation, F, D, and then we have it, force at 290 Newton. Okay, so this was really a simplistic exercise in essence. Please look at the worksheet. That worksheet is due on Monday. Tuesday we'll have a little Zoom meeting and we'll discuss that. Hopefully I won't be finished marking, but please submit on Moodle. Okay?